You already know what a shark looks like. You've seen them in movies, in news footage after an attack, maybe circling a cage on some documentary. You think you understand the danger: rows of teeth, cold eyes, a fin cutting through the surface, the most feared predator in the entire ocean. That fear is aimed at exactly the wrong thing, because here is what almost nobody is ever told. The thing you should actually be afraid of is not swimming near a shark. It is what happens to the ocean when there are none left. Sharks are not simply predators patrolling the sea. They are regulators, engineers, an invisible hand holding entire ecosystems in a balance that took millions of years to build. Remove them, and the system does not quietly continue with one fewer animal in it. It collapses in ways that are already measurable, already reaching things you eat and places you live. We spent a century training ourselves to fear one ending, the one where a shark finds you. The real ending, the one already unfolding right now, is far worse. It is an ocean with no sharks left in it at all. To understand what we stand to lose, you first have to understand what a shark actually is. Not just an animal, a survivor unlike almost anything else alive on this planet. Sharks first appeared in the ocean more than 400 million years ago, during the Devonian period. That is older than trees, older by some estimates than Saturn's rings, older by hundreds of millions of years than the dinosaurs. In that time, the shark lineage lived through all 5 of Earth's mass extinctions, events that erased 70, 80. In one case, more than 90% of all species on the planet. The asteroid that ended the dinosaurs. The Permian extinction, which came closer than anything in history to ending life itself. Sharks swam through all of it. Evolution does not preserve a body plan for 400 million years by accident. It preserves it because it works, because it is close to optimal for the role that animal plays. And the role a shark plays is not simply eat things. It is something closer to governance. A shark does not need to attack you or anything to change the world around it. Every shark carries a network of tiny jelly-filled pores across its snout, called the ampullae of Lorenzini. These organs can detect electrical fields as small as 5 billionths of a volt, the electrical signature of a heartbeat or a twitching muscle buried under sand in total darkness. This is not a minor sense. It means almost nothing hides from a shark, not the weak, sick, or dying, which sharks disproportionately remove from a population, keeping the rest strong. But the more important effect isn't what sharks eat. It's what their prey stops doing. The moment a shark might be nearby. Off the coast of Western Australia, at a research site called Shark Bay, scientists have spent decades studying how tiger sharks affect dugongs, large, slow-moving mammals that graze on seagrass. What they found reshaped how ecologists think about predators. Dugongs didn't need to actually be hunted to change their behavior. The mere possibility of a tiger shark nearby was enough to push them into safer, less productive feeding grounds. Researchers call this a landscape of fear. And it turns out that fear itself is one of the most powerful forces shaping an entire ecosystem. Take the sharks away, and that fear disappears. Grazing animals stop avoiding the richest feeding grounds. They eat without restraint, stripping out seagrass meadows that store carbon, protect coastlines from storms, and shelter thousands of species. The shark barely has to do anything. Its mere existence is the mechanism. Nowhere is the aftermath of losing that mechanism more measurable than in a single, quiet fishery on the coast of North Carolina. In 1928, fishers there pulled more than 635,000 kilograms of bay scallop meat from local waters every year, one of the largest scallop fisheries in the United States, a livelihood passed down for generations. Starting in the 1970s, industrial fishing fleets stripped the Atlantic coast of its great sharks. Bull sharks, hammerheads, duskies, hunted for meat and fins faster than they could reproduce. In 2007, fisheries biologist Ransom Myers and his colleagues published findings in the journal Science tracing what happened next. With their main predators gone, cow-nose rays, a species those sharks had kept in check for millions of years, exploded in number into the tens of millions along the East Coast, and cow-nose rays eat scallops. By 2004, the rays had consumed nearly every adult scallop left in the Sound. That year, the harvest had fallen to less than 70 kilograms. In 2007, North Carolina closed the bay scallop fishery completely. A century-old industry, gone, traced back to sharks that most of those fishermen had never even seen. Some scientists have since challenged exactly how much of that collapse to pin on rays alone, but the broader warning has only strengthened with more research since. Pull a top predator out of an ocean system, and the damage does not stay contained to the predator. It moves downward through every link until it reaches the part of the food web that humans depend on. Part of why collapses like this happen so fast, so unpredictably, is that sharks are not the simple, reflex-driven eating machines we've been taught to picture. For decades, scientists assumed sharks operated almost entirely on instinct. Recent research says otherwise. A 2023 review of shark cognition published in the journal Animal Cognition found evidence of long-term memory, individual recognition, spatial mapping, and social learning across dozens of species. Sharks aren't simply present in an ecosystem. Many appear to know it, the way a resident knows a city, not the way a tourist passes through one. In one study, researchers who had trained bull sharks to a feeding site found the sharks still remembered the exact location and returned within days. After 18 months with no visits at all, some species appear to recognize individual sharks they've encountered before. Some show consistent, distinct personalities, bolder or more cautious than others in the same population, tested again and again. This is not the behavior of a mindless predator. It is the behavior of an animal tracking, learning, and adapting across years. Inside a system it has occupied far longer than we have existed at all. Remove an animal like that from an ecosystem, and you are not removing a simple gear. You are removing something closer to an operating system, and we are removing it at a scale that is difficult to comprehend. A 2024 study published in the journal Science estimated that global shark deaths from fishing rose from roughly 76 million a year in 2012 to more than 100 million a year by 2019, despite a decade of new laws written specifically to stop it. Most of those deaths are not accidental. Shark fins can sell for as much as $1,100 a kilogram, driven by demand for shark fin soup, largely in East Asian markets. Fins are sliced off, and the animal, sometimes still alive, is thrown back to sink and die because the rest of the body is worth far less than the fins alone. The consequences are already visible on the reefs sharks are supposed to patrol. A landmark global study published in Nature in covering 371 reefs across 58 countries found sharks essentially absent, functionally extinct, on nearly 1 in every 5 reefs surveyed. In several countries, researchers logged more than 800 hours of underwater video and recorded a total of 3 sharks. 3 in 800 hours. Those aren't just statistics. Those are reefs quietly losing the mechanism that kept them stable for millions of years, with almost nobody watching it happen. There is something almost unbearable about the shape of this story. An animal that outlasted 5 mass extinctions, that survived the asteroid that ended the dinosaurs and hundreds of millions of years of a planet trying, again and again, to wipe the slate clean. It survived all of that. What it may not survive is us. One species in the space of a single century doing more damage to global shark populations than 5 planetary catastrophes combined. And the terrifying part was never that sharks might disappear. It's what disappears with them. The fear that keeps grazers in check. The seagrass that stores carbon and holds coastlines together. The scallops, the reef fish, the entire structure of systems that took hundreds of millions of years to balance, and only a few decades of us to unbalance. We built an entire myth around the shark as the villain of the ocean, the thing to fear when you step into the water, but the real danger was never the shark circling beneath the surface. It's the empty water after it's gone.